We are talking about direct variation today. Direct variation is a special type of linear function. The equation is y equals kx. K represents our constant of proportionality. This is something that you probably learned in 7th grade and then again in 8th. So we're talking about it again this year. We're building on it. So proportionality, the root word there is proportions. So whenever fractions are equivalent, that would be your proportion. So the way that we get our constant proportionality k, that's found by dividing y over x. So y is on top. This is similar to, remember when we look at a table, we find our slope by doing change of y over change in x. The little triangle is delta, and it means the change, the difference between y and x, or between y values. There we go. But with k, all you have to do is divide your y by your x value. You don't have to find the change because it's a proportional relationship. So let's determine whether or not the equation represents a direct variation. Remember, with direct variation, we just have y equals kx. And I do k and x both as lowercase letters. So you multiply some number by x to get the y value. So it says solve the equation for y. If it's in the form of y equals kx, then it's direct variation. So we have 2x plus 3y equals 0. So we need to solve it out, get it to say y equals. So we're getting the y by itself. I highlighted mine. So in order to get the y by itself, we need to get this 2x to the other side. So how do we get the 2x to the other side? Minus 2x, yep. (2x) and negative 2x zero out. And then we just carry down the 3y equals. And just like with y equals mx plus b, you want to put the x first, the mx first, or the kx. So in this one, we're going to put a negative 2x, but then we have a 0. So we don't need to do anything with that 0 because it doesn't change anything. So we just have 3y equals negative 2x. So now how do we get y by itself? Yeah, divide by 3. 3 divided by 3 gives us 1. So we're just left with y equals negative 2 over 3x. So the original question was, is it direct variation? Yeah. Because it's y equals kx. What does k equal? Constant proportionality. So in this equation, what is it? Yep, negative 2 over 3. Okay, let's do the next one. 2y plus 3 equals 4x. Draw your line down your equal sign. We want to get y by itself. So what do we need to move? The 3. So how do I move the positive 3? Minus 3, minus 3. Whatever you do to one side, you have to do to the other. These 3's will zero out, giving us 2y equals, I want it in mx plus b form. So which number do I put first? 4x minus 3. Still don't have it saying y equals. So what do I need to do now? Yep. And whatever you do to one, you have to do to all. So it's y equals, it says 4 over 2x. What is 4 divided by 2? So 2x minus, what's 3 over 2? We can leave it like that. Or grab a calculator and let's see. Y'all can grab a calculator. All right, whenever you divide negative 3 over 2, what do you get? Negative 1.5. Okay. So is this direct variation? No. Why? Yeah, it has a kx, but then it has this, making it not a direct variation. So no. This is just a regular linear function. We can't write a k because there is no k. Okay, let's look at how these look when they're graphed. So I want you to talk to your group about how do you think the direct variation equation is going to look compared to the non-direct variation. So talk to your group and graph them and write down what the graph is going to look like whenever it's a direct variation. Go to y equals, plug it in.
You gotta plug in the one thing.
Y equals negative 2/3 x. And then the other one is just 2x minus 1.5.
I got
Hit graph.
not what you.
Okay.
All right, so make sure you have the correct equations put in there into y equals. Everyone should have a calculator out to do it.
How did you
Okay, so let's talk about the one that's direct variation. Raise your hand if you can tell me what you see about the one direct variation that's not on the direct, that's not on the non-direct. There we go. Raise your hand if you know what the difference between the two is on your graph. Okay, right here.
It doesn't go through the, one doesn't go through the origin.
Okay, so this one goes through the origin. Right? Whenever we graph it, see how the blue one went through the origin? The other one didn't. It's because why? Because one of them's direct variation, right? And with regular direct variation, it's a positive constant. but this one isn't. So this is actually called an inverse direct variation, which we're not going to talk about that much in Algebra 1. But just know it's going to go through the origin. All right, let's look at the next one. Determine whether or not the table represents a direct variation. If the answer is the same for each ordered pair, there is a direct variation. So what you're going to do is divide y by x on each pair. So we're going to do this one, the first pair, the y value, 10.5, divided by the x value. Go ahead and divide it. Second, quit to get out of there. $3.5, okay. So we need to do the others. If they all come out to equal the same, then it's direct variation. So 17.5 divided by 5. Awesome. And 28 divided by 8. 3.5. So determine whether or not the table represents direct variation. This is yes, and k equals 3.5. So what we're going to do, if it's direct variation, then the equation is just y equals kx, 3.5 x. So let's put this in the calculator, look at the graph, and look at the table. So this is the equation. If it's direct variation, 3.5 is your k. So let's go to y equals. Clear out what's in there. Clear. And then go down to y2. Clear that. So go back up. We're going to put 3.5x. To make sure this matches the table, how do we get to the table? Second graph, okay? Oh, I don't like where this starts, so what we need to do is change the table set. So second window, table start, 0, change of table is 1. Did y'all see how I did that? Second window, which is table setup. So see how that says TBL set? That's your table setup. So second window to get there. Table start should be at 0 and change of table is 1. And now go back to the table, second graph. All right, so now that looks better. Let's see if this matches. 3 with 10.5. Yep. 5 with 17.5. And 8 with 28. Okay, cool. Now go to graph. And let's look at the how it's graphed. It goes through the origin again. So direct variation always goes through the origin. So that's going to be important to know. All right, let's go to the next section. Write a direct variation equation. Put x and y into the equation. Solve for k. Write the equation y equals kx, substituting the value you found for k. The value of y varies directly with x. If you see this, the value of y varies directly with x. Then that means it is a direct variation. So you can do k equals y over x. That's actually an easier way to find the equation. Just do y divided by x and then write the equation. So see how it says varies? Vary and variation, same. Directly and direct, same. Varies directly, direct variation. All the same words. So we can find k by doing y over x. So what's the y value? 4. And the x value is 8. So I did y over x. We want to reduce it if we can. How do you reduce 4 over 8? Yeah. So that gives us half. So k is half. 0.5, yeah. So we can write the equation y equals kx. All right. All right, let's look at the inside of our booklet. You're going to do number 1 and 2 right now. They both ask the same question. Which equation is not an example of a direct variation? You can talk to your table group, see if y'all got the same answer. Okay, do 1 and 2. All right, let's look at number 1. Raise your hand if you want to tell me which one is not direct variation. A, why? Yeah, it's like mx plus b. So this is not direct variation. All the other ones have y equals kx. So A is the one that's not. All right, number 2. Raise your hand if you want to tell me. Yes.
D.
D. Why? Okay, but tell me why.
What?
Okay, it's D.
30 off behind.
Yeah. What's going to happen to this 30? You're still going to have a constant at the end. You're not going to just have y equals kx. When you solve it out, so let's solve it out so we can show our work. So look at me solving it. Look up at the board. So you need to move the 5x to the other side. We get 6y equals negative 5x plus 30. Divide by 6 all the way through. And you get y equals negative 5 over 6x. That's fine, but we still have a plus 5, so it's mx plus b. So that's why it's not a direct variation equation. Over here, you'd have equals 0, right? That's going to just be, yeah, 0 goes away. That 30 will not go away. So that's why this one's not direct variation. All right, 3 through 5. Name the constant variation k for each equation. K equals, what does k equal on each one of these? Y equals kx is the equation. Yep, first one's 5. Second one is 1/2. Third one. All right. All right, that is all we're going to do on these notes for today. So put those to the side. Yeah, put it in the pocket.